Welcome to Programming Fluency. This is section 2.2, Integer and Character Types. So far, every number you stored was an int. In this video, you learn the other integer types, the difference between signed and unsigned, what overflow is, and the char type for letters. Let's begin. An int looks simple. It just holds a number, but which numbers? Can it hold a billion? What happens when you add 1 to the largest value it can store? And why does char, the type for letters, secretly hold a number 2? Let's answer all of these. Here is the plan for this video. First, we look at the int type and its size. Int is the default integer type, and see you will meet the sizeof operator, and see why an int is usually 4 bytes. Next, we meet two more integer types. Short is a smaller type, and long is a larger type. You will learn how to pick the right one from the range of numbers you need to store. Then we look at signed versus unsigned. Both use the same number of bits, but they split them differently. Signed can hold negatives. Unsigned gives up negatives to double the positive range. After that, we look at overflow and wraparound. You will see what happens when a value goes past its maximum, and why signed overflow is undefined and dangerous. Finally, we look at char. An ASCII, a character, is really a small integer in disguise, so you can even do math on letters. So far, every variable you made was an int. That worked fine for ages, scores, and temperatures. But C has several integer types. Each one has a different size and a different range. And choosing the wrong one leads to bugs that are hard to see. Values can silently wrap around, or a program works on your laptop but fails on a small device. You have used int since your very first variable. Now let's look at it closely. Int is the default integer type in C. It stores whole numbers with no decimal point. On most modern systems, it is 32 bits, giving a range of about -2.1 billion to +2.1 billion. 32 bits can represent about 4.3 billion different values, split between negative and positive. That is plenty for counting students or tracking temperatures, but it is not enough for the national debt or the number of bytes on a hard drive. How big is int on your machine? C gives you the sizeof operator. It returns the size of a type in bytes. Here we print the size of int, using the format specifier %zu. That specifier prints the result of sizeof, which is an unsigned type called size_t. On most desktops and laptops, this prints 4. 4 bytes is 32 bits. On some older or embedded systems, it prints 2. So if int is only 16 bits, a program that works on your desktop could overflow on a small chip. What if int is too big for your needs or too small? C gives you two more integer types. Short is a smaller integer type. It is at least 16 bits, which is 2 bytes. Its range is at least -32,768 up to 32,767. Long is a larger integer type. It is at least 32 bits, which is 4 bytes. On most 64-bit systems, long is 64 bits or 8 bytes. That gives a huge range, about -9.2 quintillion up to 9.2 quintillion. Let us picture each type as a strip of bytes. Here is short. It is 2 bytes wide. That is enough to hold values from -32,768 up to 32,767. Now here is int. It is 4 bytes wide, twice as wide as short. That wider box holds a much larger range, from about -2.1 billion up to +2.1 billion. And here is long. It is 8 bytes wide, the widest of the three. It holds a huge range, from about -9.2 quintillion up to 9.2 quintillion. The wider the box, the larger the range it can hold. Here are the typical sizes on most 64-bit systems today. Short is 2 bytes, 16 bits, ranging from -32,768 up to 32,767. Int is 4 bytes, 32 bits, with a range you already know. Long is 8 bytes, 64 bits with a very large range. Here is a simple rule. Use int by default since it is the natural word size and usually the fastest. Use short when memory is scarce. And use long when values might pass 2 billion. Each integer type has its own format specifier for print. For short, you use %HD. For int, you use %D, the one you already know. And for long, you use %LD. The specifier tells print how to read the bytes in memory. The wrong specifier does not crash your program, it just prints garbage. Every integer type has 2 variants. A signed type can hold negative, 0, and positive values. This is the default for int, short, and long. An unsigned type holds only 0 and positive values. It gives double the positive range, but no negatives. To make a variable unsigned, you add the unsigned keyword. Here count is an unsigned int, so it can never be negative. Unsigned is a good fit for things that are never negative, like counts, sizes, and array indices. The trade is simple. Both types use the same number of bits. A signed 32-bit int splits its values between negative and positive, from about -2.1 billion to +2.1 billion. An unsigned 32-bit int gives all of them to the positive side, from 0 up to about 4.3 billion. The format specifier for unsigned int is %u. What happens when you add 1 to the largest value a type can hold? The value wraps around. This is called integer overflow. It happens when an operation produces a result outside the range of its type. For unsigned types, the value wraps around, like an old odometer rolling past 99999 back to 0. For signed types, overflow is undefined behavior. The standard does not say what happens. Let us walk through an unsigned overflow, one step at a time, for a 16-bit type. We start at 65,534. Add 1 and we reach 65,535. This is the maximum. It is the largest value a 16-bit unsigned type can hold. Now add 1 more. There are not enough bits for 65,536, so the value wraps around all the way back to 0. This is the wrap moment, shown in red. Add 1 again and we simply continue from 1. Unsigned overflow is predictable. It just counts around like an odometer rolling over. Signed overflow is worse than unsigned overflow. It is undefined behavior. The compiler may wrap the value, produce 0, crash, or optimize your code in surprising ways. You cannot count on any result. Here is a real example. In 1996, the Ariane 5 rocket exploded. A 64-bit floating point value was converted into a 16-bit signed integer. The value went past the range, overflowed, and crashed the guidance software. It was a $370 million loss, all from one integer overflow. The char type is an 8-bit integer. Its main job is not storing small numbers. Its main job is storing characters. Under the hood, char holds a small integer. The ASCII standard maps integers to characters. Capital A is 65, lowercase is 97, the digit 0 is 48, and a space is 32. So in C, capital A is not really a letter. It is the integer 65 wearing a costume. Here is the same variable printed two ways. First, we store capital A in a char called letter. When we print it with %C, print shows the value as a character, so it prints capital A. When we print it with %D, print shows the numeric value, so it prints 65. Both are correct. They are simply two views of the same 8 bits. Because characters are integers, you can do math with them. Here we take capital G, which is 71. We add 32. 71 plus 32 is 103, which is lowercase g, so the program prints capital G, arrow, lowercase g. This works because the ASCII has a regular pattern. Every lowercase letter is exactly 32 higher than its uppercase partner. So add 32 to go down, and subtract 32 to go up. Here is a program that pulls it all together. It declares one variable of each type, a short set to 100 and an int set to 100,000. Here is a long set to 5 billion. The double capital L suffix tells the compiler this literal is a long. 5 billion is too big for an int, and even too big for a plain long on some systems. And here is an unsigned int set to 3 billion. The capital U suffix marks the literal as unsigned, because 3 billion is too large for a signed int. Then it prints the size of each type with sizeof, and prints each value with its matching format specifier. And remember, char is always exactly 1 byte, guaranteed by the standard. Here is a very common mistake. You have a long holding 5 billion, but you print it with %D. %D is for int, not long. What happens? The output is a seemingly random number, not 5 billion. There is no crash and no error. Print reads only 4 bytes instead of 8, so it prints garbage. The fix is simple. Use the specifier that matches the type. For a long, use %LLD. Let's recap. C gives you several integer types with different sizes, plus signed and unsigned variants, and the character type char. Choose short, int, or long based on the range you need. Signed stores negatives. Unsigned drops negatives to double the positive range. Unsigned overflow wraps predictably. Signed overflow is undefined, so never rely on it. Char is an 8-bit integer, mapped to characters through a ASCII. And match the format specifier to the type. %HD for short, %D for int, %LD for long, %U for unsigned, and %C for characters. Next, in section 2.3, floating point types, you will learn float and double, and see why 0.1 plus 0.2 does not equal 0.3.